Right, relative frequency, page 122 and 123, section 9.4. This is really about conducting experiments in probability, and the results that you generate from experiments in probability can be used to ascertain whether the theoretical probability is in fact true or not. So for example, we all know that probability, this is just me thinking out loud, we know the probability of getting a head, for example, the fair coin is 1 out of 2. We know the probability of getting a tail with a fair coin is 1 out of 2. So therefore, if I was to flip the coin 100 times and record how many heads and tails I'd get, I'd expect about 50 heads and I'd expect about 50 tails. Alright, so this is a theoretical probability, and these will be the theoretical expected figures for the number of heads and tails. So, but supposing out of 100 throws or flicks I got 47 heads, and therefore I got 53 tails. Would that imply that the coin is in any way biased? I'll write the word up there. No, because actually the number of heads and tails obtained by experiment are totally in keeping with the theoretical number of heads and tails expected according to these probabilities there. So if I was to work out the relative frequency of obtaining a head, that would be not 50 out of 100 but 47 out of 100 according to my experiment. In the same way, the relative frequency of gaining a tail by my experiment would be those 53 there. So that'll be 53 out of 100, and of course they can be put into decimals if you really want to. And that one 0.53 in the same way. Okay. That's it. So you've got some idea of what relative frequency is. So if you think of it as an experimental probability, you won't go far wrong. So experimental probability is a relative frequency, alright? Alright, change. Okay, now some real questions, page 122. A dice is rolled 100 times. Okay, a 6 appears 1/4 of these rolls. Straight away, the relative frequency of getting a 6. Very simple. Relative frequency getting a 6 is going to be 1/4. Doesn't ask us to work out how many 6s. There would be 1/4 of 100, which are 25 6s according to the experiments, but that's fine. Question 2. A spinner is spun 200 times. The red appears 25 times. What is relative frequency for red? So working down the page, relative frequency for getting a red is going to be 25 out of 200. That's a fraction, which you can then simplify to, I believe that's an eighth. Alright, it's definitely an eighth. Question 3. Alan rolls an ordinary fair dice 600 times. How many times would you expect to get a 5? Well, the actually be a theoretical probability. I won't call it RF. Just get rid of that. So the probability of getting an actual 5 would be, of course, 1 over 6. It's a fair dice, 6 faces, 6 possible outcomes. So how many times would I expect to get a 5? I'd expect to get a 1/6 of 600 rolls, and a 1/6 of 600 is clearly 100 5s. Is that alright? In fact, they're all 100 each according to theory. Would you expect to see exactly this number occurring? Give a reason for your answer. Well, no, I would not, because out of 600 throws, each throw would be random, and it will be an independent throw. Right, random and independent, therefore you cannot expect the precise theoretical probability of 1 over 6 to be confirmed. You cannot expect 100 for each number on the dice to come up, because it is an experiment, and that's all there is to it, really. Now, number 4. Ruth flips a coin 240 times. How many times do you expect to get a tail? Well, the probability of actually getting a tail is going to be half. It's a fair coin. How many tails would I expect? It'll be 1/2 of those 240 goes, and that will be 120 tails. Alright, she actually got 109. Okay then, she got 109 out of 240. Do you think the coin is biased? Well, she should have got around 120. 109 is a bit low, so we can say too low, compared with 120 expected, so biased. You could argue, if you want to, not biased. Why? Because 109 is close to 120. Now, even in an exam, if you argue it either way, then you still get your marks. So too low because you judge that 109 is too far from 120, or you can say, well, no, it's only an experiment, it's not biased. 109 is a fair result, even if you do expect 120. So either way, it's pretty good.